Our next lesson will cover solving with trig ratios. This is learning target 4. I can use trig ratio equations to find missing sides. So we have now completed all of our level 2 work. We're now moving into learning target 4, which is the very beginning of our level 3 work. To solve with trig ratios, let's remind ourselves what the trig ratios are. The different trig ratios are sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So consider this situation. We have this triangle. Of this triangle, we know that the hypotenuse is 10. We know that the x, the BC side, is what we want to figure out. And we're given a 25 angle. So if I tried to do this like our past learning targets, we would first probably try to do Pythagorean theorem. But with no second known side, we can't use Pythagorean theorem because I would have to try to figure out A, we'd have to plug in B, and we're given C. So there is not enough information to use Pythagorean theorem. Also, if we tried using special right triangles, if I were to put an n, a 2n, and an n square root 3 on this would be incorrect because this is not a 30-degree angle. This triangle is not 30, 60, 90. So how are we going to figure out this missing x side if none of the other learning targets help us? Well, that's where trig ratios come in. This is the general setup for a trig equation. We will be putting one of the ratios in the very beginning, such as sine, cosine, or tangent. Next to it will be the angle, which we're familiar with seeing. Sometimes it's a degree and sometimes it's a letter. When we're doing solving, this will always be a certain number of degrees. And then either the top or the bottom of our ratio is going to be our x, and there will also be a number that will be either on top or bottom. Here are some examples. You see, this is set up for sine of 70 degrees, and it's going to be equal to x over 5. Notice how there's a number in the angle position. This problem uses sine, the variable is on top, and there's another side on bottom. In this problem, we would be solving for the opposite, and the triangle would have had a 5 on the hypotenuse. Here's another example, tangent of 24 degrees. This came from a triangle where we were given an opposite 11 and an adjacent y. So we are solving for the adjacent side, and the angle in the triangle was 24. Let's start setting these up to solve for actual triangle problems. So in this triangle, I'm given a 62 angle. I want to figure out the x side, and 15 is the hypotenuse. X from the 62 angle is our opposite side. So this triangle is forcing me to use the sine ratio. I picked sine because of the 62 degrees. It's equal to opposite over hypotenuse. The opposite in this problem is x, and the hypotenuse is 15. To solve this, we're going to have to do the opposite of what we see. I see this as x divided by 15. The opposite of division is multiplication. If I multiply to the right of the equal sign, I have to multiply to the left of the equal sign. The problem says x divided by 15, so I'm going to multiply by 15, which is the opposite of dividing by 15. What you do to one side, you do to the other. So my x will be equal to whatever 15 times sine of 62 degrees is. So this is the moment where you will be using your calculator. It comes out to approximately, not exactly, 13.24. Now in my calculator, after the 4, there was another 4, which means I do not round this 4 up to 5 because I am rounding to the hundredths place. So this is how we use a trig ratio and equation to solve for a missing side when given very limited information. Let's take a look at this triangle. In this triangle from the 50 degrees, I'm given a 7 on the opposite side and a y on the adjacent side. There is nothing on the hypotenuse, so I don't care about it whatsoever. Which trig ratio is opposite and adjacent? Well, that would be tangent. So I'm going to use tangent of 50 degrees, and that will be equal to my opposite over adjacent. 7 is opposite, adjacent is y. In this problem, it does not say divide by a number. In this problem, it says divide by a letter, divide by a variable, divide by y. The opposite of dividing by y is multiplying by y. Do it to both sides. It sounds funny that you'd want to cross out the y's, but this allows the y now to be not in the denominator of a fraction. Let's rewrite what I have. Y is now multiplied to tangent 50, and it will be equal to just 7. My problem says y times tangent 50. The opposite of multiplying tangent 50 is dividing by tangent 50. Remember that tangent 50 is just a number. If you don't believe me, type it in your calculator, and your calculator would give you a number. So if it's just a number, you can divide by that number. Again, this says times tangent 50. The opposite of times is divide. Divide tangent 50. Don't forget to do it to both sides of your equal sign. Now that the tangents are gone from the left, my y is all alone. And I will compute whatever 7 divided by the tangent of 50 is. It comes out to approximately 5.87. Now I was told to round to the hundredths place. In my calculator after the 7 was a 3, so I do not round the 7 up to 8. In this problem, you saw the difference between putting the variable on top of the ratio versus putting the variable on the bottom of the ratio. Okay, I want you to go ahead and give this problem a try. Pause the video while you try it. Then unpause it and check your answer. Okay, here is the correct work with the correct answer so that you can do a little bit of error analysis if you did not end up with 8.97 and 6.66. Call me over and ask me a question if these are not the answers you got. As we move forward, I want you to realize that trig is meant really for the real world. To do real-world problems with trig, we need to know 2 very specific terms. The first term is angle of elevation. This is an angle that is created when rising up from horizontal. So imagine you're standing on the ground and you're looking straight out. As your glance rises up and you're looking now up, this is what we call an angle of elevation. Again, it is made from looking horizontally and then looking up, rising your glance upwards towards the sky. As an opposite, the angle depression is the angle lowering down from horizontal. So in this scenario, imagine that you're standing on the edge of a cliff, maybe overlooking the ocean. You notice that there is a boat out in the ocean. If you look straight out, you would not be looking at the boat. But as your glance lowers down, now you see the boat. Lowering down from horizontal is your angle of depression. Again, both of these start by being exactly horizontal. One looks up and the other one looks down. So let's start by drawing a picture. Remember, we're using trig, and trig revolves around right triangles. So make sure as you're drawing out your own triangle for these real-world problems that you're actually drawing right triangles. So there's a building. So here's my building. And there's a ladder that leans against this building, and of course it's touching the ground. If you want to draw out this ladder, that is fine. But notice how I have formed a right triangle. The ladder's angle of elevation, so remember this is horizontal and then rising up, is 60 degrees. The ladder itself is 6 meters. So in this problem, I'm given a hypotenuse. First up, I want to find out how far up the wall does the ladder reach. So that would be this side of the right triangle. We'll call that x. From the 60, this x is the opposite side. So I am being guided to using sine for opposite over hypotenuse. The sine of 60 degrees will be equal to opposite, which is x, over hypotenuse, which is 6. Let's multiply by 6 on both sides to remove the divide by 6. So my x will be equal to whatever 6 times sine 60 is. I come up with approximately 5.20. The reason why it's 20 is because in my calculator it said 5.196. The 6 rounds this up to 10, which adds a 1 to here, giving me 2. Now, let's answer the second question. How far from the wall is the base of the ladder? Here's the base of the ladder, and to the wall would be this side of the triangle. Now, I'm going to be using adjacent. I'm not going to use the number I got for opposite because it was rounded. Let's continue to use the hypotenuse. So for my y side, I am going to use adjacent and hypotenuse, which is cosine. So the cosine of 60 degrees is equal to adjacent y over hypotenuse 6. Again, we're multiplying by 6 because it says divide by 6. My y will be equal to whatever 6 times cosine 60 degrees is. Lucky for me, this comes out to an exact answer. So instead of putting approximate, let's put equal signs, and it comes out to exactly 3. Go ahead and read this problem, give it a try, pause the video, and then unpause it to see your answer. Here's my answer. I got approximately 39.16 feet of string. Call me over if you didn't get this answer. Okay, let's try one last example. In this example, you are standing on top of a 25-meter lighthouse. You see a boat in the ocean at an angle of depression of 10 degrees. How far is the boat from the base of the lighthouse? Let's start by drawing a little picture. So I got this lighthouse. Now I know I don't have the best drawing, and of course lighthouses are on the ocean. You see a boat, and it's out in the ocean. The lighthouse is 25 meters high. And remember, you glance out on vertical, and then you glance down at the boat to get our angle of depression. This angle of depression is 10 degrees. Now, that is not the angle inside the triangle that I'm working with, because this is the triangle I'm working with. The nice thing about an angle of depression is that this angle and the angle inside the triangle add up to 90. So I'm going to take 90 degrees and take away 10, and I end up with 80. So the angle I will work with for this problem is actually 80 degrees. How far is the boat from the base of the lighthouse? That means I am trying to find this distance from the base through the water to the boat. So I'm given a 25. From the 80, my x is my opposite side. The 25 is my adjacent side. So I'm using tangent this time. Tangent, because of 80 degrees, is equal to x over 25. It says divide by 25, so let's multiply by 25 on both of our sides of our equation. So my x will be approximately what 25 times tangent 80 is. Comes out to approximately 141.78 meters from the lighthouse. Here's one last problem for you to try to check to make sure that you're understanding this. Pause the video, give it a try, and then unpause it and check your answer. Here's my answer and my picture that helps you see how to do this problem. If you did not get this and do not understand why, please call me over and let's discuss it. Before we end, let's revisit our scale. So far, we have learned about the Pythagorean theorem. We've learned about special right triangles, and we learned how to make trig ratios. Today was learning target 4, and we were using trig ratio equations to find missing sides, which is the very beginning of our level 3 work. Don't forget to click forward and hit the submit button so I get record of you watching the video.